Hello guys, it's Mr. K, and today I'd like to talk to you about atom economy and yield. We're going to start with atom economy. So firstly, I'd like to say that it is really important for the companies to use chemical reactions that produce as much product as possible from the reactions that they have. Therefore, where a few different alternative reactions would be possible, companies will go for the reaction which has the highest atom economy. So what actually is atom economy? It's the amount of starting material that ends up as useful product. So how do we calculate percentage atom economy? Well, first you identify what the useful product is, then you work out the relative formula mass of all the products and use the formula to calculate the atom economy. And the formula is as follows. Percentage atom economy equals the relative formula mass of useful product divided by total mass of all the product, and then you multiply that by 100. And therefore you get the answer as a percentage. So let's look at how this looks on an example. So you could have this theoretical reaction where C2H5OH produces C2H4 and H2O. So what you have to take into account is that we are only really interested in the product, so you can ignore the reactants in this case. So you start off by working out the relative mass of all of the products. In this case, we have two products, the C2H4 and the H2O, and you work out the masses individually. So C2H4 adds up to 28 and H2O adds up to 18. And then again, you just apply the formula. The formula being the mass of the useful product divided by total mass of all the products, and then you multiply that by 100. So we've got 28 because our useful product in this case was C2H4. I know that there wasn't actually a question on top of this, but if there was a question, they would tell you what the useful product is, in case you were wondering. And if you've done the calculations, that should give you 60.9%. So with that, we're going to move on to percentage yield. I know we didn't talk much about atom economy, but it really is quite straightforward. So percentage yield, you could have an exemplar reaction where 1 mole of A and 2 moles of B make 1 mole of C. So for instance, if you wanted to know how much of A and B you need to produce 1000 kilograms of C, it would be quite intuitive just to do a simple calculations to work it out. However, in most of the cases, pretty much always, the reactions don't work like that. Let's say if you have 500 kilograms of A, 500 kilograms of B, that doesn't necessarily mean that you're going to get 1000 kilograms of the product, and that is due to the yield. So, percentage yield of a reaction. What is it? Well, I think we should first start with the term yield, which is the amount of product that a chemical reaction produces. And the percentage yield is a comparison of what you really produced to what you could have possibly produced in a reaction. So how come that these things are not the same? How come that what you can produce is not the same as what you're actually producing? So why is the yield not 100%? Well, there are a few reasons why. Firstly, there are incomplete reactions, so where some reactants do not end up forming the product. Under that category, we could also have the reversible reactions, where some of the products can revert back to the reactants. You could also have some losses during the experiment, such as while pouring or filtering, and you could also have some side reactions, which are unwanted reactions that compete with the desired reaction. So now that we know what yield is and why it's not 100%, pretty much never, we can actually talk about how to calculate your percentage yield. So there are two things that you need to know: the amount of product that was produced and the maximum amount of product that was possible. And then you apply Again, a fairly simple formula where percentage yield equals amount of product produced divided by maximum amount of possible product, and then you multiply it by 100. Can you multiply it by 100 because you're getting it as a percentage? In theory, you don't really have to multiply it by 100, but then it wouldn't be percentage yield, it would just be a decimal yield. So let's look at a worked example of percentage yield. What is the percent yield for a reaction if you predicted the formation of 21 grams of C6H12 and actually recovered only 3.8 grams? Okay, so we're just going to do it step by step, bearing in mind our formula. So, amount of product produced and maximum amount of product possible. Those are the two things that you always have to identify in your question. And then you just use that formula of amount of product produced, 3.8 grams, divided by maximum amount of product possible, 21 grams. Then you multiply it by 100. If you've done it correctly, in this case, you should get an answer of 18.1%. So this was quite straightforward. So what I'd like you to do is to try this question yourself before I'll go through the answer. So I'll just read it out for you. A reaction between solid sulfur and oxygen produces sulfur dioxide. What is the percent yield of a reaction if you predicted the formation of 680 grams of sulfur dioxide and actually recovered only 384 grams? So I'd like you to just pause the video now and try to do the question yourself. Alright, so hopefully you would have done the question. So we do exactly the same thing. We highlight our amount of product produced and the maximum amount possible, and we apply our simple formula of 384 grams divided by 680, and then we multiply what we get by 100 to get 56.5% in this case. You could also have some harder examples like this one. In the chemical reaction shown below, 700 grams of calcium carbonate was reacted and 39.2 grams of calcium oxide was obtained. Calculate the percentage yield. So what you should notice at the first glance is that they're not telling you what was the maximum theoretical mass that could have been produced. What this means is that you will have to calculate it yourself using a little bit more difficult way of dealing with this question. So firstly, what you need to do is you need to work out the relative formula masses of the reactant and the product. You don't need to do all of the products, you only have to do the ones which are mentioned in the questions. So the reactant, so there could be multiple reactants, there could be multiple products. In this case, we only have one reactant and two products. But you only really focus on what they're telling you in the question. So in the question, they're talking about CaCO3, okay, and they're talking about the CaO. So those are the two compounds that you need to focus on, and you need to calculate the relative formula masses for. So it's quite straightforward. Calcium has the mass of 40, carbon 12, and oxygen 16. So if you calculate the relative formula masses, the calcium carbonate has 100 and the calcium oxide has 56. The next thing that you would need to do is you need to work out the ratio of, again, the two compounds that they're talking about in the question. In this case, it's 1:1. Well, how do we know it? We just look at how many molecules we've got. So as you can see in the formula CaCO3, there's nothing in front of it. So if there's nothing in front of it, you can imagine that it's 1. It's same with CaO. There's nothing in front of it, so you can imagine that it's 1. So the ratio of moles of calcium carbonate to the moles of calcium oxide is 1:1. In the question where it's 1:1, it's actually it doesn't matter. You don't really need to know this. But if the ratio was anything different than 1:1, it's a really important part of your calculations later on. So what you do then is you calculate the number of moles of your calcium carbonate. We know that 700 grams was used and that 1 mole weighs 100 grams. So you do 700 divided by 100, and that means that in this reaction they've used 7 moles of calcium carbonate. So when you're trying to work out the theoretical yield, so the theoretical maximum mass of calcium oxide that could have been produced, you have to multiply the relative formula mass of calcium oxide by the number of moles and by the ratio. Now in this case the ratio was 1, so again it doesn't matter. But if the ratio was, let's say, 1 to 2, so 1 mole of calcium carbonate to 2 moles of calcium oxide, then you would have to multiply 56 times 7 times 2. But if the ratio was other way round, for instance, 1 mole of calcium oxide to 2 moles of calcium carbonate, then instead of multiplying by 2, you would actually divide whatever you get by 2. So the ratio is really important, but in this example it doesn't really matter because it's 1 to 1. So that means that the theoretical mass that you could have produced of the calcium oxide was 392 grams. So then you do your simple formula, percentage yield of calcium oxide. We know that we've only produced 39.2 grams against the maximum possible 392. We divide that, we multiply it by 100, and we get 10%. I will leave the link in the video description to the website, which has a lot more of questions like that with answers, okay, for both the easier and the harder questions, so you can have a go yourself. So thank you very much for listening, guys. Leave me any suggestions and additional questions either in the comment section or you can email me directly.